Hello year 9s, welcome back to Mr. Chan's videos. How are you guys? I am going to talk about statistics today, but we're gonna focus on estimating the mean of group data. So let's begin. I remember last videos we went through how to do mean and median. Okay, so there's a quick recap. Mean is the average of the data set, alright, the center of the data. And median, on the other hand, is the number that is right in between the whole data that you have collected. Okay, so they are similar, but in a way they are different. Most of the time, what you would get is your mean and your median should be roughly the same once you have calculated them. So for these videos, we are going to talk about the how to find mean if you going to get a group of data that has already been grouped. Okay, so the example that I'm going to show you right here is over here. Look at this set of data, it already has been grouped up. Okay, so the learning objective is the student will be familiar with group data and able to find mean and draw frequency histogram. So it's quite self-explanatory. The keywords are class interval, midpoint, alright, which is your interval midpoint, which I will explain more. Product means after you multiply something with another number, the thing that you get is a product. And frequency histogram, I'm going to teach you how to plot that as well in a group for group data. So let's begin. When continuous data is grouped in class interval like this, okay, this is continuous. Continuous data. It's something that you count, okay. No, sorry, something that you count or record or measure, okay. So there are two types. Remember, discrete numerical data and also continuous numerical data. So continuous means something that that you have recorded. So like a weight of pumpkins, or in this case is a speed of car travel. Okay. What happens is when you actually group them up, you don't know the actual data. Okay, and it is therefore very almost impossible to find the exact mean. Therefore, however, we can estimate the mean by using the midpoint of each of the group data. What it means here is, let's look at this for example. The speeds of 129 cars were measured at a particular point on a country road, okay? They are shown in the table alongside. Estimate the mean speed of the drivers. So here we have a group of data. As you can see, what it means here is there is one car travel between 40 and 50k. 3 car travel between 50 and 60. 17 car travel between 60 and 70k. 39 cars 70 to 80, and so on. Okay, and you can't, since this is the only table that has been provided, you don't actually know what's the exact value. You don't know that one car that has been traveling between 40 and 50. You don't know what's the exact speed. It could be 42, could be 45. It wasn't given, okay, but it still won't stop us from finding the mean. So how do you do it? We're gonna go to the next page. So what happened is this, it has been done for you. So however, I'm going to teach you how to find the mean of a group data. First, you're gonna have to create 2 extra columns. Alright, so the column number 1 is interval midpoint and column number 2 is product. So what that means is, if I'm going to do it, I'm going to have to extend this out. Okay, most of the time you just extend them like what it is. So you need to find the midpoint, okay, the interval midpoint, which is what's the midpoint between 40 and 50. Alright, between 40 and 50, the middle is 45, which is here. Okay, hence that's what it means by midpoint. Literally, you find the middle number between the two. Okay, between the two range. So the midpoint between 40 and 50 is 45, 50 to 60 is 55, 60 to 70 is 65, etc. Okay, so pretty much half, half, half. And then once you locate that, what you will have to do next is you will have to find the product. So the product is pretty much what the product here is pretty much what 45 times 1, okay, and that's 55 times 3. You just need to multiply the midpoint to the frequency. So that's 65 times 17, and that will be 75 times 39. For 85 times 48, 95 times 17, 105 times 4. So once you multiply that, you will get what is called product. And from product, you actually need to add them all up, okay, which is here sum. So to find mean is actually sum of all data divided by the number of sample size, which in this case is 129. So it's pretty easy. So once you found the product 10355, all you need to do is divide it by 129, and you will get 80.3 kilometers per hour, which is your average speed for the speed of driver on that country road at that moment. So you just need to follow these rules, okay. Step 1, you need to create interval midpoint, which is the middle one. Okay, so create 2 columns. Okay, so beforehand you need to create 2 extra columns. And step 2, find the interval midpoint. Okay, so 1 is your interval midpoint. Step 3, find the product, which is the interval midpoint multiply by the frequency. Okay, and step 4, once you got that, what you need to do is find mean, which is the product divided by number of sample size. Okay, so your product here is is that one. Look at this, which is that, and your sample size is 129. Okay, sometimes you actually need to count it, but in this case it is given to you with 129. So I'm going to show you one more example of me doing it, and then we'll call it a day. Please make sure you write the notes down for this, okay? So let's move on. So 50 adults each kick a football. Okay, so everyone kick footies, and what happened here is that one table has been made which shows the distance of ball travel in the air before it bounces. Okay, so we have that 4 group of data. So we have distance, obviously how far the ball has been kicked, and also frequency, which is how many adults out of that 50 actually kick into those categories. So if I'm gonna explain this table, it means 10 adults actually kick between 20 to 30 meters. 19 adults actually kick between 30 to 40. 14 adults kick 40 to 50, that's pretty good. And 7 adults actually kick between 50 and 60 meters, that's really impressive. Okay, if you can kick between 40 to 50, I would say you're pretty good kicker. So you have to do A, B, C, and D. I have to do it actually. So first I have to draw a frequency histogram, which I'm going to show you how to do, and B actually talk about whether it is possible to determine the furthest distance the ball has been kicked. Okay. C, extend the table along to include interval, midpoint, and product columns, and D, estimate the mean distance the ball was kicked. So let's do A first. So frequency histogram. So frequency histogram, it is like column graph without the gap. Okay, no gap in between. So let's start. I'm gonna draw this. I'm gonna maybe do it like this. As you know, this is always your frequency. Okay, your y-axis will always be your frequency, means how many times that particular data has occurred. And we have here, actually I will make it a bit bigger because I'm afraid I won't have enough space. I'm very big drawer. And always start with 0, and that is your distance travel, distance kick. Okay, distance kick by adult in meters. Okay, so 0, and you always go through the smallest number with 20, and then to 30, 30 to 40, 40 to 50. You want them evenly spread. Please do not follow my example, as in you make sure you do it on the grid paper because it will be neater, and also please use a ruler as well. And frequency, the frequency highest is 20. Okay, so I might do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So when you plot your graph, you make sure that has able to include all your all your data without looking too crowded. Okay. most of the time I will advise you to do a big one so that you can actually draw them a lot clearer. So let's begin to putting all the data. So between 20 to 30 meters, there are 10 adults who kick that. So what you have to do is, that's between 20 to 30, that's 10 adults. Okay, please use a ruler. Okay, the fact that I'm drawing on iPad made it pretty hard to use ruler. However, you will definitely have to use ruler. Between 30 to 40 is 19. Okay, so 19 is right in between 18 and 20. So, and 40 to 50 we have 14 here, and 50 to 60 we have 7. So there you go. So the title would be the distance of football kick by adult for 8 pounds. Okay, there you go. That's the title. So that is my frequency histogram. So B. Is it possible to determine the furthest distance of the ball was kicked? Please refer to here. Okay, not this one, here. So when a continuous data is grouped into a class interval, the actual values are not known. Therefore, it is impossible to calculate the exact mean. So what happened is the exact number is actually unknown. You can't actually tell because it already been grouped out. So it is not possible to determine the furthest distance the ball was kicked because the actual individual data wasn't available. Okay, so that answers your B. And C, extend the table alongside to include mid-bay interval and product column. So that's quite easily, so just follow again, use rulers, follow some example on the previous example. Okay, so interval midpoint. Alright, so what I will do, because of the limited space, I will actually just write interval mid, okay, which represent midpoint and your product. So interval midpoint for the first the first class interval is 25 because it is right in the middle of 20 to 30, and 30 to 40 is 35, and then 45 for the next one, and 55 for the next one because it's right in the middle. And after that, I need to count products. Products, remember, is midpoint times frequency, which is 25 times 10, 35 times 19, 45 times 14, and 55 times 7. Okay, so if I'm gonna use my calculator quickly, um, 25 times 10, that's 250. Alright, I don't need calculator for that. I do however need 35 times 19, which is 665, and then 45 times 14, which is 630, and 55 times 7 is 385. Once you got that, you actually need to calculate total. Okay, so the total pretty much just add them all up. So 250 plus 665 plus 630 plus 385, which will give you 1930. Okay, so from there, I actually got this one and that one. Let's see. And D estimate the distance of ball was, I mean the mean of the distance. Well, the ball was kicked, so mean distance. It is a total sum value. Alright, sum value means you all add up the product, or which is your product. Okay, divided by sample size. Sample size. So total is 1930 sample size. So 50 adults was kicking it. So pretty much 1930 divided by 50, which gives you 38.6 meters. Okay, the unit is meters because it is how the distance of the ball kick in meters. So there you go. That's how you find the mean distance of the group data if the actual data if the actual individual data was not given. Okay, so please write down your notes and let me know any questions that you have, and good luck. Cheers. Bye.